to Beryl International School. A beautiful morning to you. Today I'll be introducing you to basic science, and our topic will be gravitation and weightlessness. This class is reserved for Jss1 students. Gravitation and weightlessness. So during the course of this lesson, we are going to learn how to define gravitation and weightlessness. We are also going to explain the solar system. We are going to explain the effects of gravitation on objects. We are going to describe the rotation and revolution of the Earth. We are also going to outline the description of the eclipse, climate, and seasons. Now, let's take the first objective. One would wonder, what is gravitation and weightlessness? And how does it have to concern with the solar system? How does it have to affect the gravitation on objects? Or how does it have to affect gravitation on objects? How does it involve rotation and revolution of the Earth? And how does it affect the eclipse or climate and the seasons of the Earth? So I would love you to sit back, relax, pick up your pen and your paper or your book, and just pay attention to this class. Now, gravitation. So gravitation is also known as gravity. Gravity or gravitation is the natural phenomenon by which objects with mass attract one another. This means that gravitation or gravity has to do with the attraction of objects to one another. Now, this has to do with the gravitational force. The gravitational force or gravitational pull. And then it mustn't get the contact. For instance, I have this marker with me. When I let it go, the force of gravity will pull it down automatically. So that is gravitation of gravity over here. So gravity is also the force with which the Earth attracts objects towards its center. This brings about gravitational force or gravitational force field. Everything around the Earth experiences a gravitational pull. Now everything around the Earth experiences a gravitational pull or gravitational force. That is because all the objects has weight. Everything or every object in this planet Earth has weight. So it must adhere to the gravitational force or gravitational pull. Let's look at this other definition of gravitational pull. Gravitational pull, also known as gravitational force, is the force which acts on a body across a distance without making any contact between the source and the body. Now let me explain this. Gravitational pull or gravitational force is the force which acts on a body. Now this is an example of a body. I have a book here too. This book can also be seen as a body. This is an object, or we have two objects with me right now. So gravitational force here is the force that acts on this body or that acts on this object that attracts the object down to the center of the Earth without making contact with it. In other words, the force of gravity would attract this object to come down without making contact, without any contact. Okay, let's look at it once again. That gravitational pull or gravitational force is the force which acts on a body across a distance without making any contact between the source and the body. Now, gravity also exists between the Earth and other bodies. You know, when we're talking about other bodies, we're referring to other planets, referring to other planets. So, this is why things or objects which are thrown up fall back to the Earth. Since the Earth is a gravitational force field, so everything around the Earth is under the pull of gravity. This means that because of the gravitational force on this planet Earth,
anything you throw up,
let me use this marker,
anything you throw up must surely fall
down because of the gravity. Meaning of, let's go back now to meaning of weightlessness after we've defined gravitation. Now, meaning of weightlessness. Now, before I go through this, I need you to know that nothing in this planet Earth is without weight. So when we're talking about weightlessness, we are simply referring to the phenomenon, we are simply referring to the feeling of weightlessness. For instance, when a body is floating, or when a body is, I don't want to use the term fly, floating in the sense that maybe you're up somewhere and you now throw something. The feeling in the air, when you're flying or when you're falling in the air, the feeling of weightlessness, as you have this feeling of weightlessness when you're in the air. So that is what we're referring to be weightlessness, because there's no object that's without weight. Even the smallest or the tiniest piece of paper has weight, and that is why when you throw it up, it will certainly come down because of the law of gravity or the gravitational force. So let us look at the meaning of weightlessness. This is the phenomenon experienced by people during free fall. I talked about free fall earlier. Although the term zero gravity is often used as a synonym, weightlessness in orbit is not the result of the force of gravity being eliminated. This means it's not as if the force of gravity is being eliminated or is not there, or even significantly reduced. It is not. So weightlessness is a feeling of being weightless. It does not mean having no weight. Nobody or material is without weight or is weightless, since they all are under the effect of the force of gravity. So you agree with me here that no object, no thing is without weight. So weightlessness here refers to the feeling when something is in a free fall, or when an object or when a body is in a free fall. During that period, it is now weightlessness. It is because it is weightless. So let's look at the second objective, which is to explain the solar system. So we have it right here. The solar system. Now the solar system consists of the sun and all the bodies that orbit the sun. This includes the planets. We could say the 8 planets and the 16 moons, the 16 known moons. Now let's talk about this. Before the year 1930, we used to say that we had 8 planets, as though we do have the giant planet. As the planet is being divided into 3 segments, we have the giant planet, we have the terrestrial planet, and we have the dwarf planet. So before the year 1930, we used to state the 8 planets, beginning from the arrangement from the sun down to Mercury, down to, but now we now introduce the Plateau, or rather the Pluto, as the 9th planet. Now there have been these arguments about the Pluto being a planet, that it's quite small and should not be classified as a planet, that as though it's seen as a dwarf planet. But science has revealed that the Pluto can also be seen as a planet because it has about 50 times or 10 times as large as the planet Earth. So let's take a look at this now. The solar system, once again, consists of the sun and all the bodies that orbit. The term here, orbit, is like the same as something is spherical, where something is around something. That's the meaning of the term orbit. So when the sun and all the bodies that orbit the sun, including the planets, the 8 planets and the 166 known moons, 3 dwarf planets, and we have the Mediterranean, Pluto, and the Aries, and their known moons. Now, asteroid moons, meteors, and comets. Now let's look at this. It also includes the gas and the dust found in the space between layers or larger bodies. Now let's look at the 8th planet. The 8th planet of the solar system, with Pluto, orbits the sun at various distances. Don't forget about the term orbit once again. In order of distance from the sun, these planets are: number 1, we have the Mercury, we have the Venus, Earth is next, we have the Mars, Jupiter, Saturn, Uranus, Neptune, and the last one here that was discovered in the year 1930, Pluto. This planet, like I said, was discovered in the year 1930, but astronauts now came together to, the National Association of Astronauts worldwide now came to agree that it should be considered a planet in the year 2006. Now let's take a look at each planet. The sun makes up about 99.9% of the solar system. The solar system is, let's say, the remaining 0.1% is taken up by the giant planet. That is Jupiter. And let's look at this. Let's take a listen. The solar system is grouped into 2 classes, including the dwarf planets. Now, according to the Astronaut Association, as of 2006, who agreed that the planet which was discovered in 19, according to the astronauts who agreed that the planet Pluto, which was discovered in the year 1930, should be seen as a planet in the year 2006. Hence, if we are grouping planets into 2, we don't have to add the dwarf planets. Don't forget we mentioned the dwarf planet before, we're still going to mention them again. So we do have the terrestrial planet, the giant planet, and the dwarf planet. So let's begin with the terrestrial planet. There are 4 terrestrial planets in our solar system. These are Mercury, Venus, Earth, and Mars. Now, these 4 planets can also be referred to as the inner planets. They can also be referred to as inner planets because they are made up of rocks and heavy metals. They are made up of rocks and heavy metals. And also, they can also be called the rocky or telluric planets. Once again, I said they can be called the rocky or telluric planets. So now let's look at the giant planets. So we have the giant planets. There are 4 giant planets in our solar system. These are Jupiter, Saturn, Uranus, Neptune. These are the 4 giant planets. Don't forget, we first talked about the terrestrial planets, and we mentioned 4 terrestrial planets, and we also have 4 giant planets, which makes it the 8th planet we usually find in our solar system. But now, due to the research, the recent findings, we now have an accepted planet here. So I still have to put it in the midst of the dwarf planets. So we have 3 dwarf planets. We have the Ceres, the Pluto, and Eris. So this one here, don't forget, was discovered in the year 1930 and was accepted to be a planet in the year 2006. Okay, take a record of that. Now, these are gaseous surfaces compressed into fluid and relatively small solid curves, rocks, usually rocks and iron. Most of their globe being liquid. The exception is that of Pluto, whose composition is still unknown. Scientists, however, believe Pluto is like a ball of rice, similar to the satellites of the giant planet. It is, and also has to do with an orbit so ancestral that is sometimes nearly the sun than, or nearer to the sun than Neptune. Okay, so please, I would love you to do something for me. I need you to be busy at home, so I need you to carry the research for me. I mentioned 3 groups of planets in the solar system, and I did mention the terrestrial planet, I mentioned the giant planet, and also the dwarf planet. I did explain to us what the terrestrial planets are made up of. I mentioned rocks and other materials. So I would love you now to discuss the composition. This means what it is made up of. So discuss the composition of the following planets. I'm talking about the giant planets here, which we have the Jupiter, Saturn, Uranus, Neptune. So you're going to tell me what these planets are made up of, and also the dwarf planets here, as mentioned above. So I would love you to do this for me. Please ensure to carry this assignment. Don't just state them, discuss it. In fact, I want you to write a page or 2 for me. So please do that and submit as soon as possible. Thank you very much. In our next class, we're going to consider these other objectives. We took just these 2 objectives today due to time constraint. So we're going to take these other objectives in our next class. Thank you and stay safe. Remain blessed.